Hi guys, it's 8:30 at night and I am at home making some videos to help you guys out. Hopefully this will help. If you hear my husband or my kids yell for me, I apologize. We're going to start with number 23. Number 3 is the one that talks about, do most teens recycle? To find out, an AP Stats class asked an SRS of 100 students at their school whether they regularly recycle. How many students in the sample would need to say yes to provide convincing evidence that more than half of the students at the school recycle? The Fathom dot plot below shows the results of taking 200 SRSs of 100 students from a population in which the true proportion who recycle is 0.5. So they did a simulation. Part A says, suppose 55 students in the class sample say yes. Explain why this result does not give convincing evidence that more than half of the school students recycle. If you were in hour 3, you want to refer to the video that I made over this. Because that hour it was a little bit of a struggle in class. Hour 4, you already have the notes. In the video, though, if you're in hour 3 or in hour 4, I went through some steps. And the first step is, what is the sample result? And I'll highlight that right here. And the sample result is what they calculated, what they got. And if you notice, if you notice in the problem, if I can get over to it, okay, give me 1 second. They said that 55 out of the 100 students, right, say yes. Sure. Give me a second again. I'm still getting used to, forgive me, patience, right? Next, you have to figure out, well, what's the probability of that sample? So what's the probability of getting this 55 right here out of 100, which is 0.55. So what I do is I go over to this dot plot here, and I look and I say, okay, 0.55 is right here. So I want to look and say, how many dots got 0.55 or more extreme than that? And I count up all those dots in that area. And if I count up all those dots in the area, that's the probability of the sample result. So there's 43 dots that were at least our sample data. So that means 0.55 or more divided by 200 total dots. And that gives us a probability of 0.215. Okay. So now we know our sample result, what the proportion is. We know how to figure out the probability of getting that sample result. And now we draw our conclusions based on the simulation. That's big for me. Making sure you have that word used right there. Based on the simulation of 200 samples, that's all the dots, we would expect to get this sample result. What sample result am I talking about? This sample result. 21.5% of the time. Again, step 2 is how I got that. This is not unlikely. If you want to say likely, that's fine for now. Why is it not unlikely? Because it's not 5% or less. So, this is not unlikely. We have no reason to believe more than half the school students recycle. All right. Part B. Suppose 63 students in the class in the sample say yes. Explain why this result gives strong evidence that a majority of the school students recycle. All right, and remember, a majority is over 50%. And right now, our truth is 50%. So we now want to know, why do we have strong evidence that it's over 50%? We go through the same steps again. Step 1, our sample results. 0.63. How did I get that? If you look at the problem, 63 students in the class sample say yes. So step 1 is getting our sample results. Step 2, from up here, same step. These are all the same steps. Step 2, the probability of the sample result. What did I say before? I go up and I look now at my dot plot. And I look and say, how many dots got that same sample result? And only one dot had a result more extreme than that. And it doesn't look like there's any that are equal to it. And that's right there, that dot right there. Okay? So again, you're counting up. If you look at the step 2, you're counting up how many dots were at least, excuse me, it paused on me because I'm at 10% battery. So I'll just repeat what I said. On step 2, I'm looking at how many dots had at least the sample results. and at least 0.63. If you look, there's only one dot there that is at least 0.63. So I take 1 divided by 200, and I get a half of a percent, 0.5%. I sum up again based on this simulation of 200 samples. We would expect to get the sample result 0.5% of the time. This is unlikely, so we have evidence that the majority of students recycle. So I'm just answering that question based off if it is likely or not likely. All right, hopefully that helped. If you're still struggling, you're going to have to come see me and we'll have to work on it together. Next, I had a question on number 9, due for a hit. A very good professional baseball player gets a hit about 35% of the time over an entire season. After the player failed to hit safely in 6 straight at-bats, this is important there. A TV commentator said he is due for a hit by the law of averages. Well, first of all, we have never learned the term law of averages. We have learned the term law of large numbers, which means as our sample size increases, or our trials increase, our experimental probability will approach the theoretical probability. So he's using the term law of averages incorrectly. We would say law of large numbers. Next, we need to state that seeing based off of 6 straight at-bats, okay? That's based off 6 straight at-bats. That sample size is not large enough to apply the law of large numbers. We saw that with our tack flipping activity. In our tack flipping activity, we saw there was a lot of variation at the beginning, and once we got to 50 trials, things were really leveling off. In fact, they were probably leveling off after 25 trials. 6 trials is not enough, and that's what's wrong with number 9. And I believe, if I'm correct, you had to state what was wrong with the comment. All right, hopefully this helped. I hope you're having a good night, and we will talk to you guys tomorrow.